Let's make a simulation of a helicopter with counter-rotating blades. Let's go into WebGL mode, and we will draw a plane. And then we'll turn off stroke. And we'll fill this one with brown. Make the canvas a little bit bigger. Okay. And let's put push and pop around this because we're going to do some transformations. Okay, and then let's make this first blade rotate, then we'll duplicate it, and then we'll have our second blade. So we're going to create a variable that tracks the rotation amount, and that starts at 0. And then here, we're going to rotate on Z by that rotation amount. And then we're going to use the mouse's X position to determine the rotation speed. But for the moment, let's just do this. Just increase it a little bit. So there we have it rotating. Okay, that's a good start. And then let's get the other blade. So copy, paste, paste. We'll do a gray one. And this one's going to go the other direction. So we say minus. So now we have two counter-rotating blades. And let's make it so we can tilt the blades first. So that suggests we're going to rotate the whole thing on X. So rotate X, and we're going to map the X location of the mouse pointer, which goes from, no, we're going to do Y, which goes from 0 to height minus 1 into tau, which is 2 pi, according to some mathematicians, all the way around the circle. So this is a quarter of the way around the circle, and this is no rotation. Okay, let's see if I got this. Yeah, that's fine. So we're either looking edge on at the blades, and since they're planes, P-L-A-N-E, like the geometrical shape, they have no thickness, so you can't see them if you're completely edge on. Okay, that's good. Now let's make the speed change depending on the X position of the mouse. So zrot plus equals map mouse X, which goes from 0 to width minus 1. 0, between 0 and 1. So 0 would be no change in rotation since the last frame. 1 would be 1 radian change of rotation. So let's see this now. There we go. So no rotation at all to lots of rotation change per frame. Okay, the blades are happening, they're existing in the same space, so we need to move one of them. So let's, for the gray one, let's translate it, not on X or Y, but on Z by 5 pixels. So that'll move it a little bit. There we go. Okay, and now let's add a rotor, not a rotor, like an axle. I forget what it's called on the actual helicopter. So this will be black, and it's not going to rotate the same way. It's going to be a cylinder. but not a cylinder facing that way. It needs to be rotated on X a quarter of the way around. And there we go. So you can imagine that rotor. Go look up a picture of a helicopter with counter-rotating blades if you want to see it. That axle is really quite sophisticated because it's two shafts that are spinning in opposite directions. Okay, so that's an example of a JavaScript p5.js program in 3D simulating counter-rotating helicopter blades. See ya.